to Chemtech Laboratory Tutorial. Today we'll be looking at rate of chemical reactions. Rate of chemical reactions. What are the rate of chemical reactions? When we talk about rate, we are talking about the time taken for a concentration of reactant or concentration of the product to be formed while reactant to what decrease. So it means if I start a reaction, for example reaction between nitrogen and hydrogen gas will give us what? Ammonia. If you start that reaction, you see that the concentration of the nitrogen and concentration of the hydrogen will be what? Decreasing. Then the production for the ammonia concentration will what? Increase. So in that case, we call the average rate of disappearance as that of what? The concentration. While the average rate of appearance will be that of what? The product. So let's take for example the average rate. If a reaction A will give us what? B. This will be a reactant and this will be what? Product. So what will be the average rate of A and the average rate of B? It means the average rate of A, it becomes average rate of disappearance of A will be change in A at time t minus change in A at what? Time 0 all over what? T at minus t at time what? 0. So this is how the average rate will be. But since we said it's disappearance, meaning here will become what? Minus. So in general, it becomes minus change in the concentration of A all over change in concentration, all over change in time. So the average rates of disappearance of A will be change in the concentration of A all over change in time. And this minus indicates that the concentration of A is decreasing with time as the product is being what? Produced. So what will be the expression for the average rate of appearance of B? So we simply write average rate of appearance of B will be equals to change in the concentration of B all over change in time. So what is the difference between disappearance and appearance? The difference in the equation is what? The minus sign. This minus sign indicates that our reactant is decreasing in their concentration, while the product is increasing in what? Concentration. Because the moment you react two things together, the reactant will have to completely react and what? Product will be what? Formed. And as the reactant are reacting, their concentration is what? Decreasing, because new things is being what? Formed. So that is what rate of chemical reactions attain. Now how do you now express this rate of chemical reaction in our general equation? In a general form of equation, when we say general form of equation, we mean when A, for example, plus B reacts with C plus what? D. Now this A, B, C, D represents the number of moles. That is the stoichiometrical number for A. B is stoichiometrical number for what? B, and C like that for all the equation. Now if we have this general equation, it means how do you express rates? Expression of what? Rates. How do you express the rates of reaction? How do you express the rate of reaction? In expressing the rate of reaction, you simply say 1 all over A. Remember that A is a reactant, and because A is a reactant, it means we will go with what? Minus. Why do we go with minus? Because A is a reactant and A will disappear. So in disappearing means it's decreasing in concentration. So minus change in the concentration of A all over the stoichiometry times what? Change in time. So it will be in this form. So also you say equal to 1 all over B, change in concentration of B all over change in time. Then equal to 1 all over C, change in the concentration of C all over change in time, which is equal to what? 1 all over D, change in concentration of D all over change in time. So look at it properly. For A is a reactant, so we put minus. B is a reactant, we also put what? Minus. C is a product, so you don't need to put minus because product will increase. D also is a product, so product will also what? Increase, so we don't put minus. So this is how we express rates of chemical reaction. And how do you express it? We said your stoichiometry. We considered your stoichiometry, and your stoichiometry should be 1 all over A. So that means if you have 2 here, it will become 1 all over 2. If you have 3 here, 1 all over 3, and so on and so forth. So we are going to be taking calculations on this and see how we can relate this rate expression to our calculated values. Taking example on how to express rate of chemical reaction. For example, write the rate expression for the following reaction in terms of disappearance of each reactant and the appearance of each product. So they gave us ammonia reacting with oxygen to give us nitrogen oxide and water. So how do we do the first one? You simply write 1 all over 4 minus change in concentration of ammonia all over change in time. Then they said for each, so this is rate of disappearance because the ammonia is a reactant. Then for oxygen, rate of disappearance of oxygen will be equals to minus 1 all over 5 change in concentration of oxygen all over change in time. Then the next is the product. That means the product is called what? Rate of appearance. Rate of appearance. So it becomes 1 all over 4 change in the concentration of nitrogen oxide all over change in time. Then also rate of appearance of water will be equals to 1 all over 6 change in concentration of water all over change in time. So this is how to express the disappearance of each reactant and appearance of each product for the first reaction. Now we will go for the second reaction. The second reaction, this is oxygen to give ozone. So it becomes 1 all over, that is rates of disappearance. Rate of disappearance is equal to 1 all over 3 minus change in the concentration of oxygen gas all over change in time. And the rate of appearance, which is the ozone, appearance is the ozone because this is a product, so it becomes 1 all over 2 change in concentration of oxygen all over change in time. So we'll take the second question. The second question is the rate of reaction for the combustion of methane is written as this. write a balanced equation for the reaction. So meaning we should use this rate to write a reaction. And how do you do that? You see, rate is equals to this equal to this equal to this. So if you look at it from the beginning when we talked about rate of expression, you see that where we are putting minus is what? Reactant. So it becomes CH4. That means this is a reactant, CH4, plus you look for another one that is a reactant. This is minus, so it's a reactant. So you say O2, then the product to give us, look at this product is CO2, and this, because it's plus, is what? Is also a product. Now this has a coefficient of 2, so you put 2 there. This have a coefficient of 2, you put 2. And the rest do not have any coefficient. They have 1, 1. 1 is arbitrary. So you look at it and look at your reaction. Is it balanced? Because they said write a balanced equation for the reaction. So you see that it is what? Balanced. So that is how to answer rate expression and of chemical reactions. And now we are going to give another question to look at how we can calculate them when giving it. So let's look at this other question. They said ozone gives oxygen. How is the rate at which ozone disappear relates to the rate at which oxygen appear in the reaction above? Your own is just to say rate is equal to 1/2. Remember, it is minus because it's a reactant. Change in concentration of ozone all over change in time. And 2, you will therefore write equal to, because they say how does it relate? It means you will relate them by equating them. Equal to 1/3 change in concentration of oxygen appearance all over change in time. So this is the relationship of rates at which ozone disappear relating to the rate at which oxygen appear. Now the second question. He said if the rate at which oxygen appear is 6 times 10 raised to the power minus 5 at a particular instant, at what rate is ozone disappearing at the same instant? Are you seeing it now? So it means the rate of appearance, which is rate of appearance, rate is equals to what is appearing? Oxygen. Is what? 1/3 change in concentration of oxygen all over change in time. So this rate is given to us as what? 6 times 10 raised to the power minus 5. So rate is equal to 1/3 change in concentration of oxygen over change in time. So when you cross multiply, you see that the rate, the value, which is the rate of appearance, is equals to 6.0 times 10 raised to the power minus 5 times 3. So 3 times 6 is equals to what? 1.8 times 10 to the power minus 4 molarity per seconds. Remember that is concentration, change in concentration over change in time. So it becomes molarity per second. So the next one, they said at what rate is ozone O3 is disappearing. So we still need to relate that value to the rate at which ozone is disappearing. So it simply means that you will put the value 1.8. You have gotten your rate. This is how it relates. It's relating by 1/2 change in ozone all over change in time equals to, you know, this value we've gotten it to be what? 1.8 times 10 raised to the power minus 4 molarity per second. So your own is to now relate it, or you can simply do it in this manner also. leaving it as what? Rate, which is 6.0 times 10 raised to power minus 5 equals to 1 all over 2 minus change in what? Ozone all over change in time equals to, we have this value 1 all over 3. Are you seeing now? 1 all over 3, and we got this value to be what? Times 1.8 times 10 raised to power minus 4. So what do? You simply relate either these two or these two. So when you relate these two, like I said, you multiply 2 by this, and you have the change in appearance, disappearance of the ozone. There's minus here, so it becomes minus 1.2 times 10 raised to power minus 4 molarity per seconds. It's either you do it this way, or you can also do it by relating this to this. That is, you relate the ozone, disappearance of the ozone, to the appearance of the oxygen. So it becomes 1 all over 3 and 1 all over 2. Remember that there is minus, we are relating them. So if you cross multiply, these two becomes here, so it becomes minus change in concentration of ozone all over change in time equal to 2 over 3 times 10 raised to power, times 1.8 times 10 raised to power minus 4. And when you do your division, if you multiply this by this, you have 3.6. But if you divide it by 3, it becomes 1.2. So you still have the same value to be 1.2 times 10 raised to power minus 4 molarity per seconds. So thank you. Please keep on watching Chemtech Laboratory tutorial, where we give you updates on simple chemistry as we have just done. Keep watching, liking and subscribing. Bye.